Hey everyone, after several years of ownership, it's not unheard of that you may have problems with your Hayward AquaRite salt chlorine generator, specifically with regard to the display or the knob, or the button or the switches, or even the lights. You may also find that either stiff or when you press the button in, it causes the display to do funny stuff. Mine doesn't, but that can happen. Same thing with the switch. Now mine in particular is not directly outside, nor is it exposed to the elements as we see here. However, you do have to consider it is near the pool and the chlorine can cause oxidation on metal, as well as some of the supplies that I use for the pool. They can affect metal around it over time as well. Now Hayward is happy to sell you a brand new display for prices not terrible, $155. And fly-by-night companies are willing to sell you all the PCBs together for $166 with 12% off if you want to take that risk. But before dropping any money, there's generally a quick fix on the free, so let's do that now. This video is part of a collection of videos pertaining to the Hayward AquaRite salt chlorinator. If you'd like to see my other videos about the salt chlorinator, just click the link in the top right corner. We'll take you to the listing. As always, this pool repair begins with shutting off the breakers because your swimming pool is not worth dying over. Keep in mind, this device has two large capacitors, so even when you cut the power, you can see there's still power. And when that display goes out, there's still voltage, so you may want to walk away for several minutes. Several minutes later, I'll now pull the cell cable out, and then under on the bottom we got our flow sensor. I'm going to pull that one out too. Pulls out like a phone cord. Then using a properly fit flathead screwdriver, we'll remove the two screws holding on the front cover. It is possible on the second screw the cover could lean forward and fall out, so use caution. And I'm removing my cover by sticking my finger through the cell hole. I should really use the notch on top because we can see those capacitors are right there. We can see our board as a daughter board mounted onto the main board. Here's those two capacitors that could store energy even after being unplugged and ruin your weekend. I always like to point out, if you're getting no indication whatsoever, check this fuse right here, this 20 amp fuse. We're going to pull it out with a pair of pliers. Gentle wiggle back and forth will get it loose from its seat. And I can see from a visual indication that it's fine, though it doesn't show on camera. I would definitely recommend an ohm meter for continuity checks. This one is good. I'll seat it right back in with the pliers. The daughter board is affixed to 4 delicate plastic stands that we see right here. I could wiggle it, and the connectivity is on the bottom. Here's the stands 1, 2, 3, and 4, with several pins going through the bottom white connector. Now, if your switch here is broken off or your screen is black and cracked, obviously you're going to be swapping this part out. However, if you're going to be servicing it, we're also going to be removing it in the same fashion. Very gentle compression fittings on the end hold this board in place. You generally don't need to squeeze these, but if you need to, you can very gently with a small pair of pliers to release it. I pull the board square off and don't do this, but I'm just demonstrating it. Don't bend the board on an extreme angle because you'll bend the pins going from the daughter board to the main board. And there are the pins right there. QD electronics cleaner is sufficient for the next task, but if you want to spend a whole lot of money, you can buy deoxit. This is what I generally use. I happen to be out of it. Our first order of business, we see the connector for those pins, and I'm just going to hit it with the contact cleaner. Get it all in there. We don't have to worry about the contact cleaner on the board. It is safe for electronics. To limit making a mess, I'll put a paper towel under the pins before I spray these pins, and then I'll wipe them several times to remove any debris from them. Now with the paper towel having the cleaner on it, I'll clean the pins with the paper towel, and they clean right up. Note that the other side of the pins J2 is soldered in. Those pins do not come out of the main board, which is just as well because the contact is good. I did bend a pin slightly on removal, so I'll very carefully with my fingernail bend it back into position, not to overbend it, which I did, but now all the pins are straight. Give it one last clean. The switch has a lot of resistance. If we look inside, we could see some of the contacts have some green on it. Hitting it with a little contact cleaner on both sides. I'll then take the switch and just bring it back and forth over and over again to the on-off position, and I could feel it freeing up as I do it. It's a big difference. Between the contact cleaner and moving the wipers back and forth, all the contacts on the switch clean up really quick. I'll repeat this one more time, spraying it again to flush out anything that's been collected from the first event, and then I'll just move it back and forth again, and it's really smooth. The push button and the potentiometer don't have a very clear path to spray any spray in them. However, the potentiometer can simply be rotated back and forth. The wipers on it would be self-cleaning. For whatever reason, a lot of debris appears in the lowest LED, so I'll just spray that right out now with the electrical cleaner. Give it a tap, and yeah, clean it right up. There is a coating on the board that goes over everything. I checked the condition of that coating, and it is, for all purposes, intact on this side. So we'll have a look at the other side now. And on this side, we can see the board is completely covered with the coating. Nothing's burnt, nothing's damaged. Inspection shows it to be okay, so it's worth testing out back in the unit. So we'll bring the board carefully back into position, first aligning the pins on the bottom, and then the 4 holders, and snap it back into position. We can now confirm visually that all the pins went through this connector. I'll place the cover back on now, locking the bottom in first, and then pushing it up against the top so I can place the 2 screws in. Remembering not to tighten the first screw until the second screw is in, or you'll not be able to line up the second screw. Installing the second screw, we could then tighten that one all the way down, and then make our way back to the first screw, tighten that one down. I'll take a moment now to spray the flow sensor with some contact cleaner, and then I'm going to install it several times into the unit to clean the wipers. And then I'll just leave it installed. I'll do the very same thing with the cable from the cell, installing it in and out several times with contact cleaner applied just to clean up those connections. It's all back together. We'll fire it up and start testing. Making my way around to the breakers to flip them back on. We have screen and LED indication. We'll try out the push button first. Seems to be working fine. Also, the flow sensor started flashing as it picked up the priming of the pump. That switch is smooth, like brand new. That switch is night and day difference of what it was just before. We could test the potentiometer before I do. What I want to do is check to make sure I know what setting it's on exactly. I pressed the diagnostic button till I got the percentage, which is 34. We could see the P showing percent, and now I can move it back and forth. And the device is on the off position, so it doesn't matter what I set it to. It's not having any effect on the generation. Moving that knob back and forth will clean the wiper on the potentiometer, so it's a good idea, especially since it usually sits in one location. They do tend to oxidize in the location they sit, so moving them back and forth does help things out. Checking the function of the switch, we know that it runs smooth, but we can see it went to generating on auto, superchlorinate on superchlorinate, back to auto, so the switch is working fine. And that concludes this video on the maintenance or swap out of the PCB display board on this Hayward AquaRite salt chlorine generator. I hope you found this video enjoyable, entertaining, and informative. Do me a favor, hit that like button down below, helps me out a lot when you do, and hit that subscribe button for more videos like this when they come out. Again, I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?